Hi everyone, and welcome to our final report. This is Team 62 Analytics, and what our team did was create an interactive GM dashboard that helps with player selection. I'm Laura Dominiak. I'm going to kick us off here before passing it over to Stephen, who will walk you through the dashboard itself. The first thing that our team wanted to review with you is the problem statement. So it's important to note that there are 30 Major League Baseball teams in 2021 with an average payroll of around $3.5 billion. This is pretty crazy considering that each MLB franchise is worth only around $1.85 billion. Average player salaries were close to $4.5 million, nearly 10 times the league value. And there was a huge single player contract for Mike Trout for $426 million over the course of 11 years. These are astronomical numbers that we're working with, so it's really important that our GM is able to predict a team that makes playoffs and competes in the World Series. Roster management is no longer an exercise in the GM's instincts. Rather, GMs are flooded with tons of statistics and analytical values that they need to make a decision. So what our team did was create this GM dashboard that allowed a GM to be armed with the analytical tools that can consume data and present optimal roster moves in consideration of constraints such as team play role. As I mentioned before, to account for this problem, Team 62 created an interactive GM dashboard, which we will display later on in this discussion. So the second part that I'm going to walk you through is the business problem. And what happened was a GM came to us after having a losing and not so great 2021 season. They wanted to have a much better 2022 season and wanted to use our interactive dashboard. The GM came with the following constraints, which we'll walk you through. Stephen will walk you through later on in this discussion. But some of the constraints include, most importantly, the roster needs to win a World Series championship. Salaries must stay under $97.5 million, so that's $72 million for field players and $25.5 million for pitchers, respectively. Field players cannot exceed 26 players. Bullpen players cannot exceed 9 pitchers. Both pinch hitters and designated hitters cannot exceed 1 player. And there needs to be a total of 35 players on the roster. Some other constraints that we had too, so only pitchers who have pitched in a minimum of 30 innings and who have appeared in 80 appearances last season are eligible for the dashboard. And we want to exclude recommended players from the Red Sox, Yankees, and Houston. The team unfortunately hasn't had a lot of luck trading with these teams, so we wanted to kick them out of our analysis. The last bit of the analysis are the position constraints. So for catchers, we need exactly 3. For first baseman, we need exactly 2. For second baseman, a minimum of 1. For third baseman, exactly 2. Shortstops, a minimum of 2. Left fielders, exactly 3. Center fielders, a minimum of 2. And right fielders, exactly 2. Pitchers, there need to be exactly 9. Pinch hitters, exactly 2. And designated hitters, exactly 2 as well. So this is the business problem we're dealing with, and I'm going to pass it off to Stephen, who's going to walk you through the dashboard, show you all the awesome features, and show you how we put these constraints into a real live implementation.
Hi everyone, my name is Stephen Baez. I'm on Team 62 Analytics, and today I'm going to walk you through the General Manager Dashboard, which is a tool that Team 62 has been working closely with general managers to develop. The intent of the General Manager Dashboard is to provide GMs with visibility into their roster and to identify how player selection can ultimately impact wins and increase a team's chances of making the playoffs and winning a World Series. Over the next hour, we'll explore the business problem that Laura had identified. We'll also look at different use cases that this dashboard can serve going forward as a GM's objectives change throughout the course of the season. And we'll explore different features that have been included in the dashboard as well. As we can see from the dashboard, it's broken out into 3 main sections. We have the player optimizer, which is the baseball field in the center with player images. This is comprised of 2 linear programming optimization models, one for field players and batters, and another that was developed specifically for pitchers. Beneath that, we can see player statistics. So looking at this specific example that we opened the dashboard up to, we can see that 31 players were returned, 26 of whom are batters, 5 of whom are pitchers, and then we can see aggregate statistics of those players returned by the optimization model. There are other ways of interacting with the dashboard and we'll view the constraints tab in just a moment. Um, but on the constraints tab, you have the ability to determine how your starters are selected, and the players that we can see on the field are essentially our starters that the model has identified. And we can determine based on a number of attributes which are the most important for us to take into consideration in determining who our starters are. Um, we can also look at our full roster. So again, we can see our starters on the field, but if we wanted to better understand um, who was returned by the optimization model, we can see our infielders, outfielders, as well as our bullpen. Hovering over a player, we also can see specific statistics associated with their 2021 season. So this is helpful if we want just more insight into that player. We can see their player card. And then we have what's called team standings on the top right. And at a high level, and Stephen will go into this in just a moment, this is designed to essentially predict the number of wins that the players returned by the optimization model um, will contribute to in the upcoming season. And we can see the number of wins in comparison to the wins of other teams for the 2021 season, as well as their payroll. So the baseball here represents our optimized roster. In this case, it's predicted to win 96 games. Our payroll was set to $17 million. Our 26-man roster, which is another way of comparing teams, is roughly $14.8 million. And when we look at how much we're paying per win, we're paying roughly $200,000 per win. And this is really helpful in the sense that as we begin to change the constraints and objective statement in our optimization model, that will ultimately influence our team standings based on our predictions. Beneath that, we have the player cluster analysis. And the player cluster analysis is meant to provide a GM with insight into other players that may be a good fit for the ball club. So based on the constraints and objective statement of the optimization model, we have identified the best player in each position. Whereas the player cluster analysis will identify other players that weren't necessarily returned by the optimization model that are also very similar to those players that we did return from the optimization model. So this provides a GM with the ability to look at other players that may also be good fits, but may not have been the best fit that the optimization model had returned back. So over the next hour, we'll go into more detail into the underlying models. There's also our write-up as well, which discusses these models in great detail, which we'll make available separately. Lastly, on the left-hand side of this dashboard, we have filters that allow a general manager to essentially interact with this dashboard, and they can select from different teams that they want to either initiate trades with or potentially restrict, and they can select certain players that they may want to restrict as well based on their contracts. So these are players that may be signed through the end of 2020 or maybe free agents that they can restrict the output to and have the optimization model rerun as well. So again, well, over the next hour, we'll take a look at different use cases. We'll also explore the business problem that Laura had identified. And then we'll look to see how this dashboard not only answers those specific questions, but can also be repurposed to serve a more general purpose by general managers. So next we'll take a look at the constraints tab, which is designed to allow a general manager to interact with the optimization models. So located on the top left of the general manager dashboard is a menus button, which hides two additional buttons to the constraints and player analysis tab. So we'll first take a look at the constraints tab. And here we can see a number of different parameters that the end user can interact with. And these parameters are associated with different constraints and different objective functions that are ultimately passed through into the optimization models. Additionally, on the right-hand side, we have what's called mission control. And this is essentially a series of parameters that allow the general manager to interact with key assumptions that we made from a modeling perspective. So here they can identify what measure they want starters to be determined based off of. So it can be those who increase the team's overall batting average in their specific position, slugging percentage, on base percentage. In this case, we have defaulted it to team 62 wins, which I'll pass it over to Stephen in just a moment to explain in more detail. We can also identify what percentage of the time do we believe our starters will be playing. And this is important because, as we discussed the predictive model when we navigate back to the general manager dashboard, we can weight starters accordingly based on what percentage of the time we believe they'll be on the field. And that can be passed through to the predictive model to weight those players accordingly. And it ultimately will influence the number of games that this team is predicted to win. And then we have the max player salary. And this is essentially setting a max threshold for any one particular player. We would not want to exceed a salary of, in this case, $22 million. And this is slightly different than the objective functions on the left-hand side that we'll review in just a moment. In the center, we have individual position constraints. So for every position, we have the ability to determine how many players we want the optimization model to return. So we'll look at right field, and this is currently set to equals to 1. Again, we can enter in any value that we deem relevant. We can also change the equality statement. So in this case, we have it set to equals to, but we can very easily select from any of these 5 options, which are less than or equals to, greater than or equals to, or greater than. On the very far left-hand side, we have our different objective functions and ways of interacting with the optimization models. And it's important to remember that there are two optimization models. We have one for field players and a separate one for bullpen players, which are pitchers. The reason being is that each is trying to maximize a slightly different objective statement. So for field players, they may want to maximize the team's on base percentage, whereas the bullpen may want to minimized a pitcher's or the bullpen's ERA, for example. So because of those two different objective statements, essentially two different optimization models, linear programming models, had to be created based on the player's position. So this is actually passing through the constraints and objective functions to an R server, which is running in real time, and it's feeding those results back to Tableau. And so we'll just take a look at some of the constraints, and then we'll run through our specific business example in terms of how this dashboard was designed to answer the business problem that Laura had mentioned. So here for field players and batters, the end user or general manager could enter in the annual max salary that they're looking to spend on field players and batters. And in this case, they're looking to spend $15 million. They can also identify an objective statement from the dropdown. So here we have a listing of objectives that we had deemed relevant through exploratory data analysis. So we have team 62 wins, which I'll pass it over to Steve in just a moment to explain in more detail. They can also maximize on base percentage for the entire team, slugging percentage, RBIs, batting average, hits, home runs. So based on the course of the season, as the needs change slightly for a ball club, a general manager could essentially identify players that would increase any of these objective statements, which would ultimately influence the players that return back. Beneath that, they have minimum at bats, and minimum at bats is meant to restrict players that either don't have the experience that the general manager may be looking for, and is also meant to restrict outliers. So through data exploration, we had identified that there are instances where you have players that have overinflated statistics. So you can think of a player who has had 5 at bats throughout the course of a season, and they happen to go 4 for 5. They would have overinflated batting averages, slugging percentage, on base percentages as a result, which wouldn't be representative of if that player was to have played in, let's say, 50 games and had at least 80 at bats. So this is really meant to restrict some of the outliers as well as identify more experienced players. Beneath the at-bats is a player count constraint where the general manager could set the number of players that they're looking to return back. So in this case, we had it set to 26 players based on the example that we had opened the dashboard to. But we can very easily toggle this to any number as long as it's greater than the individual constraints on the actual field itself for each position. Um, so with that said, I'm going to pass it over to Steve, who will walk us through one of the objective statements that we've introduced, which is Team 62 wins.
Thanks, Stephen. Hi everyone, this is Steve Karasik, part of the Team 62 Analytics team. And I'm going to take a few minutes right now and discuss how we did some of our team-based predictive modeling. So really what we were trying to do here was to create a model that could show in a 162 game regular season how a team with a given set of baseball statistics, how many games they might actually win. Um, we weren't trying to create the most accurate model in the world in a sense, the true prediction obviously was something we were striving for, but we're really looking to create what we would classify as a useful model. So what's a useful model? In our context, a useful model is going to be something that fits into the linear optimization framework of our dashboard. So again, that linear nature is something that we needed to incorporate in our final model. And most importantly, what we really want to do is make sure we're providing insights to the GM on the relative trade-offs between the attributes of a team, for example, like ERA versus batting average. Okay, so why a linear model? Linear models, or specifically simple linear regression, clearly are not the most mathematically sophisticated models, but we think that it's actually quite the appropriate model for this application. Linear models have some nice characteristics. As I mentioned, we can use linear models as objective functions in linear optimizers, and the linear optimizer is really at the core of our dashboard. Higher order models that you might see from things like random forest or neural networks or what have you are valuable in a predictive sense, but have some difficulty fitting into that linear optimization framework. So again, while we did run those models, and I'll talk about that in a bit, our final model again was based on linear regression. Linear models have some nice properties, that the predictions of sums are the same as the sums of the predictions. This is important when we're going to be looking at groups of players and trying to apply our model at a group setting based on statistics that are from individual players. This is going to be critical when, again, we submit these players to our optimization framework. One of the nice things about linear regression is that the coefficients have natural meaning in terms of the trade-offs between the attributes. So for example, if we look at ERA, based on the coefficients of ERA or earned run average, and compare that to the coefficient that we might see on some other feature, the ratio of those coefficients give the natural trade-offs between them. In a sense, how much of one feature can I substitute for how much of another feature, which is an important consideration for a GM. And finally, linear models have the nice feature that they can be extrapolated. So when we construct a model, we might, because we're looking at team data, that data is going to tend to, center itself. We're not going to see extremes again because the team-based data is based on averages. Now, when we look at individual players, some of their statistics might fall outside those ranges we saw in the team. So in order to, having models we could extrapolate, again, is a feature that we were looking for. All right, so what do we come up with? This blue box at top sort of summarizes our wins prediction model. And it works like this. It says that on a 162 game season, the predicted amount of wins is going to be a constant, in this case 4.57. We're going to subtract 1.5 times a special flag. That's either 1 if the team is in the National League or 0 if it's an American League team. And this is to account for minor differences in things like the designated hitter. We'll take batting average, in this case expressed, a batting average, say 300 will actually be the number 300 times 4.3. We have two features called slugging spread and on-base spread. Slugging spread is the slugging percentage minus batting average. And slugging percentage looks at your total bases achieved. It's kind of like your batting average, except that you get more weight for home runs, doubles, and triples. On-base spread, again, as we look at our on-base percentage, which is going to include any hits you get plus walks or any other way that a player is achieving a base. So that's always going to be higher than your batting average, just like slugging spread. So again, on-base spread is just your traditional on-base percentage minus your batting average. We subtract 13.3 times WHIP. WHIP is your walks and hits per innings pitched. And then we subtract off ER, or 14.2 times ERA. ERA is just earned run average. And then we have below in the table, again, these definitions. Excuse me one sec. Okay, so how did this model do? And I should say that a lot of the analytics, mathematics, more the heavy-duty details of the modeling is in our written documentation that we've previously submitted. So please refer there for details. Again, this is a higher level overview. But again, how did this model do? Well, the model actually has some great properties. It's got an R squared on our test set, and I should have mentioned that our test set was 70% of the teams from 1995 through 2021. We did hold out 2020 because of the COVID situation, and since there weren't a full season wasn't played. And we also held out 2021 as a special test case, which I'll talk about in a second. So again, on that test set, we saw an R squared close to 86%, which was great. All the coefficients are significant. So when we look at the statistical output of linear regression, one of the analytics we can get is that are the coefficients we're getting actually significant? And in all cases in the model, they were. In fact, they were significant at like the 99.99% level. Coefficients are the correct sign. This is important. So again, we think about batting average. The higher batting average you have, you would hope that the team wins more games. That's what the model says. If you have higher spread of slugging, you again hope the team wins more games. That's what the model says. And same thing again on our pitching statistics. Lower pitching statistics, either in WHIP or ERA, should result in more wins. And because we've got negative coefficients on those features, that's exactly what the model is doing. I should mention that you're not going to see some other types of baseball stats. Like, for example, there's not fielding statistics. The team didn't find that there were very good aggregated fielding stats that we could apply at the team level, even though we know they exist pretty well at the player level. We did try to incorporate some base running statistics like stealing and caught stealing, just didn't improve the model that much. So we went with simplicity and really only include the variables we thought that were going to improve the model. Model does not suffer from correlation of the features. This is an important aspect of the model because we know that we can trust the statistics on the coefficients, that we're not seeing cross effects. Really the features we included can be thought of as independent. So again, making that trade-off between, for example, hitting and pitching makes sense when we know that those features are not showing correlation. A technical point, we find that the residuals are well behaved. So we know that the rest of the statistics, for example, like R squared that we're seeing out of the model should make sense. We're not getting numbers that are inflated or deflated. A special sort of fun test case is what you see in the white box here. Again, as I mentioned, we held out the 2021 season. And then what we did is we applied the model to all the statistics that the teams had in this just completed 2021 season. And we looked how the model did. Well, in fact, we have both the actual wins you see on the left, predicted wins on the right. We did that for both the American League and the National League. And we found that on the National League, our regression model predicted 2 of the 3 division champs and actually 4 of the 5 playoff teams. On the American side, we got all 3 division champions and 4 out of 5 of the playoff teams. And you can sort of see to the right, sometimes the model over-predicted a bit, sometimes it under-predicted a bit, but it really preserved that rank ordering of teams, which is important for the GM, because what we're trying to say is how is this team going to fit in relative to the rest of the league? And we find that the model does a nice job of preserving those rankings. So that said, I'm going to return back to my colleague Stephen, and it's been a pleasure working on this project.
So with that said, we're just going to explore the remaining constraints, which are for pitchers in the bullpen section here, and then we'll take a look at the specific business problem that Laura had described earlier in the presentation. So similar to field players and batters, we also have bullpen constraints. So in this case, we can also set a max salary that we're looking to spend on bullpen players. We can identify objective statements as well. So similar to what Stephen had just mentioned, We can also introduce Team 62 wins as an objective statement, which looks to maximize that linear model um, to predict wins for pitchers. We can also set a threshold for the minimum innings pitched, so it acts as an ability to identify more experienced players as well as remove outliers. And then we can set a bullpen size, so in this case equals to 5. So with that said, we're going to take a look specifically at the business problem that was presented to us by a general manager, and we'll look to see how this constraints tab is really designed to help facilitate um, some of those problems and return back players that meet those specific criteria set by the general manager. So now we'll take a look at the specific business problem that this dashboard was originally developed to answer. So navigating back to the original business problem in which a GM needs help selecting a roster for the upcoming 2022 season, and the GM has provided Team 62 with a number of different criteria that must be satisfied. We can begin entering in those various constraints on the Constraints tab. So the GM is looking for a roster that maximizes their chances of winning a World Series in the 2022. So with that said, we would update the objective statement to Team 62 wins, which increases our chance of winning games throughout the course of the season. So we'll update that for both field players as well as for our bullpen. And this is going to pass through that linear equation directly to the optimization model that Stephen had described. Salaries must stay under $97.5 million, and the GM actually broke out the salaries based on field players as well as the bullpen. So for field players, they're looking to spend no more than $72 million. So we'll enter that value in. And then for the bullpen, no more than $25.5 million. So we'll enter $25.5 million. Field players cannot exceed 26 players, and bullpen players cannot exceed 9 pitchers. So we're just going to set this equals to. Again, we can play around with this, and then we'll come back to this throughout the video as well. So we're going to set field players equal to 26 and bullpen players equals to 9. Only have pitchers who have pitched a minimum of 30 innings, and then field players who have made 80 batting appearances. So that can be reflected within the constraints as well. So the general manager is looking for experienced players. And then from a individual position perspective, we have a listing of position constraints that we'll just quickly enter into the constraints tab. So this GM is looking for exactly 3 catchers, 2 first basemen, a minimum of 1 second baseman. So we'll change the equality statement here. Exactly 2 third basemen, a minimum of 2 shortstop, and then we can take a look at outfield. So left fielders exactly 3, center fielders minimum of 2, and then for right fielders they are looking for exactly 2, and then for pitchers exactly 9. And so we'll update our bullpen also to 9. Okay, and it looks actually for designated hitters and pinch runners, they're looking for exactly 2. Okay, so before having the model run, I'll quickly just discuss what it's looking to accomplish in this case. So because we have our total field players and batters set to 26, anytime we have a equality statement that's greater than or equals to, it's essentially going to determine additional players in those positions that help to maximize our objective statement, which in this case is Team 62 wins, while remaining underneath our salary constraint and meeting our minimum at bats. So we would never expect this model to return back any more than 2 right fielders or any more than 3 left fielders because we set those equality statements equals to. But anytime we select greater than or equal to, we're essentially telling the model to assess across the other positions that we've also set a similar constraint. So for other shortstops, other second basemen, other first basemen, select ultimately those players that help to increase our objective statement, which is Team 62 wins. So again, it could select all center fielders that help to do so. It could select a combination of center fielders, shortstops, first basemen, etc. So it's essentially going to rely on the model to determine which players help to maximize that objective statement. So I'm going to click back, which will force the model to run. It takes roughly about a minute and 40 seconds. During that time, the model is going to um, first identify players that meet the conditions that we've just entered. It's going to pull back those player images that we had web scraped and saved locally. It will also compute the aggregate statistics of those players. Um, it will determine from a predictive perspective how many games those players are expected to win. And lastly, it will also determine other players that are similar through player cluster analysis. So I'll pause the video and I'll return back once the model has completed. And you can see in the background as this is running, I'll just move this up. You can see how it's actually going through each player and evaluating who should be returned back and who should be a starter. And you'll see how it continuously reweights the entire team. So you can see how it's making selections, then based on other selections for players in different positions, it's rebalancing to essentially maximize our objective function. So I'm going to pause the video and I'll return back once the optimization model finishes. So here we have our players returned by the optimization model, and we'll just go ahead and explore some of the features on the dashboard as well as the players that were returned and how this information might be relevant to a general manager moving forward. So this, of course, would be our recommendation to the general manager based on the constraints that he had provided or he or she had provided. We had entered that information into the constraints tab and essentially these are the starters that were returned based on our mission control statement, which was to select starters based on those players who maximize the team's Team 62 wins, as Stephen had discussed. Additionally, we can see the entire roster. So these are players that are both starters as well as bench players, broken out by infielders, outfielders, designated hitters, as well as the bullpen. And towards the bottom of this baseball field here, we can actually see aggregate statistics of those players returned by the optimization model. So here we can see that the model had returned back 35 players, for which 26 were batters, 9 were pitchers, and then we have aggregate statistics, again, weighted based on those individuals who were starters. Their statistics were weighted accordingly based on the amount of time that they would play on the field, which was set to 90%. So here we can see batting average, on base percentage, slugging, ERA, as well as whip. So this is helpful. This gives us a bit of insight in terms of collectively how these 35 players would perform as a team based on aggregating their statistics and weighting them accordingly based on starters and bench players. As we begin to hover over, we can also get additional information about any of these players. So looking at Jesse Winker, we can see his statistics. Again, he was selected as the starter for left field. But towards the bottom of this player card, we can also see other outfielders that were returned by the model. And because outfielders are so interchangeable in the sense that a left fielder can play center field and a center field can play right field, it's good to know what other players were selected just in case the general manager would want to move these players around accordingly. He can see which other players were also selected by the optimization model. As we look around the dashboard, on the top right, we can actually see predictive statistics around these optimized players that were returned back. So here we can see that this team would amount for 115 wins. So it's predicted that this team would win 115 games in the upcoming 2022 season. Our payroll is $80 million. So thinking back to the original business problem, we wanted to have a maximum team salary that was under $97.5 million. And here I was able to maximize our objective statement, which was the Team 62 proprietary logic. And in doing so, was able to maximize that objective function at roughly $80 million. Our 26-man roster, which is a helpful way of looking at just our field players, so not including our pitchers, and looking across other teams is roughly $70 million, so just under. Again, we were looking to stay under $72 million, so that constraint was satisfied. And then when we get to look at wins per dollar spent, we can see that on average, we're spending upwards of $600,000 per win. And it's helpful to see other teams here as well, because as we begin to look at other teams, and this table currently is sorted in descending order based on wins for the 2021 season, we can see here that there are other ball clubs that are paying significantly more. In fact, as we look at bigger ball clubs like the Yankees, the Red Sox, they're paying upwards of $1.5 million per win, and we are currently predicted to pay $600,000 per win. So a big sizable difference of $900,000, which is especially when you think to potentially bringing on other players, that's additional money that could be spent on bringing in additional pitchers, additional designated hitters, other players as well, or just spending that money elsewhere in the organization. So a big savings there. And again, we could go through different constraints to see if we could maximize this number, or if there was a different objective statement that we were looking to possibly use, whether it's to maximize on base percentage or batting average, depending on the certain situation that the GM may find himself in. This is really helpful because it gives us a good indicator of this team's ability to win games, and ultimately winning games is what's required to make the playoffs. And that increases our likelihood of winning a championship as well. Kind of as Steve had mentioned in the Team 62 linear regression model that we had built, that framework is critical to predicting wins and ultimately to winning a championship. So as we continue to look around the dashboard, we also have player cluster analysis. And I'm going to pass it over to Aaron, who is going to give us a walkthrough in terms of the analysis that he conducted. And then I'll discuss how that analysis was incorporated into this dashboard and how we made it more interactive for a general manager to use going forward.
Thank you, Stephen. My name is Aaron Tellis, and I'm one of the analysts for Team 62 and the analyst that worked on the similarity analysis for our GM dashboard. The similarity analysis was performed for the purpose of allowing GMs to have the ability of leveraging the optimizer's output recommendation for players that are not just arbitrarily similar on a random set of attributes, but are similar in the characteristics that help predict their ability to help teams win. In this manner, we pull the GM out of the constantly changing media fads and new golden grail measures, and instead provide them with a purely data-driven approach to evaluating players. Again, more information is available within our technical documentation, but at a high level, we use logistic regression for feature selection in our k-means clustering analysis. Using the features that were found to be statistically significant in predicting playoff appearances for individual hitters, pitchers, and fielders, we are able to provide the GM with similar players along the attributes that matter. For example, for the pitchers, we use number of walks as a feature, which essentially records the number of times a pitcher allows a hitter to earn a base without hitting a single, double, triple, or home run. And we also use on base plus slugging percentage against. This captures how well hitters will perform against a specific pitcher in terms of batting averages and their ability to earn bases. We consistently validate our analysis before each season to provide the most relevant clustering approach and update our technical documentation to highlight these key changes. In addition to the k-means clustering analysis, we provide the GM with the ability to cluster using principal components to understand the underlying factors which drive performance for each respective type of player. In practice, this is accomplished through a drop-down selection within the dashboard which allows GMs to select the first and second principal components for pitchers, hitters, and fielders. We highlight in our appendix of our technical documentation the player statistics that are driving the values for the principal components. And again, we update the values before each season so that GMs and analytic teams are privy to the changes in the underlying player stats, which are driving differences seen between players. In totality, the use of the similarity analysis serves as an additional add-on feature to the optimizer to provide a holistic approach to evaluating players. With this additional feature, the GM can use this in conjunction with the optimizer's output as a tool to inform better decision making for the purpose of building a stronger team that ultimately results in more wins. Thank you.
Thank you, Aaron. So next we'll take a look at how Aaron's analysis was incorporated into the dashboard and some of the features that we made interactive to a general manager as they explore the player cluster analysis. So to initiate the player cluster analysis, a general manager would first need to identify a position or a player that they're interested in looking to see if there are other players similar. So they can do so in one of two ways. They can identify a starter and click on that starter's image on the field, or they can navigate up to full roster, display all the players returned by the optimization model, and essentially click on the player from there. So in this case, we're going to take a look at center fielder Juan Soto, and we're going to click on the player to initiate the cluster analysis. This takes just a moment. It's actually going to look at other center fielders or other outfielders who are similar to Juan Soto based on Aaron's cluster analysis. It will also look for players who are less than Juan Soto from an annual salary perspective. Again, we have to stay underneath the payroll that was specified by the GM and was passed through to the optimization model. So that's a mandatory criteria that also gets passed through each time you select a player. And then it's also just going to pull back the player images and display them on the scatter plot on the bottom right. So this process just takes about a moment, and then it's very interactive afterwards, and we'll demo some of those features. All right, so navigating down to the player scatter plot, we can look at other players that were returned by the player analysis. And here we can see Juan Soto on the top right, and you can see his name beneath him, indicating that he was the player that was selected for the comparison analysis. And we can see other players that were also returned. And these are center fielders, outfielders who are less than Juan Soto on an annual basis, who are also similar from a cluster analysis perspective. And the color around the player indicates the cluster that they fall into. And a player can fall into two clusters based on their offense cluster as well as their defense cluster. And to interact with this scatter plot, there's a menu button on the top left. And from here, you can determine if you want to view the offense cluster for that player or the defense cluster. You can determine if there's an x-axis and a y-axis that's more appropriate, and we have a number of different x-axis and y-axis options available, from batting average, on-base percentage, all the way to the principal components that were generated for field players, hitters, as well as pitchers. The same is true for the y-axis. And then at the very bottom, we can actually see the cluster that that player falls into. So the star here indicates that the player that we selected, which in this case is Juan Soto, he falls into the tier 1 hitter, which is this blue cluster. And if we hover over, we can see other players also on the scatter plot that fall into this blue cluster of tier 1 hitters. But we can also see other players that are similar to Juan in the sense that they're outfielders, they have a similar salary, if not less, that fall into different clusters that we may want to be interested in exploring as well. Clicking on any particular cluster will filter the scatter plot to reflect just those players. So again, we can hover over orange, and the moment we click on orange, which is tier 2 hitter, we can see those players returned by the optimization model, or those players returned by the player cluster analysis model. And what's really interesting is that we can actually pass through the principal components that Aaron had generated through his player cluster analysis. So I'm going to select, in this case, I'm going to select the hitter PC1 component as my x-axis, and I'll select hitter PC2 component as my y-axis. And what's interesting here is as we begin to hover over, we can see that these players do fall into distinct clusters. So when showing the principal components, there is distinguishable separation between these different cluster groups. So very interesting, as well as very dynamic in the sense that you can hover over to identify different players, at which point their player card will also appear. Um, so a lot of relevant and helpful information to allow a GM to really explore different players that weren't necessarily returned by the optimization model, but maybe good secondary picks. And to illustrate just one more example, I'll select a pitcher, for example, um, and we'll have the optimization model, the player cluster model recalculate. And this will take just a moment. And right now it's set to offense statistics, but we'll quickly switch this to X and Y axes that make the most sense. And if a GM is unsure of what statistics make the most sense from X and Y axes, they can always leave it to default, at which point the model itself will determine the most relevant X and Y axes based on that player that was selected. And here we can see, based on the pitcher that we had selected, this pitcher falls into a tier 8 pitcher cluster. And we can see other pitchers that fall into a similar cluster. So this is from a defense perspective, whereas previously with Juan Soto, we were looking at the player cluster analysis from an offense perspective. We can also look at the pitcher components, principal components that we had generated. So this is looking at PC1 for the x-axis, and then pitcher component 2 for the y-axis here. And similar to what we had noticed when looking at the offensive clusters, that there are distinguishable barriers between these different clusters, as Aaron had discussed based on some of the fields that he had clustered using. So again, a lot of relevant information here for a GM to explore that serve different use cases. And we approach this with the intent of making this interactive as possible.
So lastly, in making our recommendation from a player perspective and roster perspective to our general manager, when looking back at the original business problem, the GM had requested that we restrict trades across specific teams, those being the Boston Red Sox, Houston Astros, as well as the New York Yankees. With that said, there are additional filters on the dashboard located on the left-hand side, one of those being teams. So from this dropdown, we can select teams or deselect teams that we want to trade with. So we'll deselect Boston, we'll deselect the New York Yankees, and lastly, Houston Astros. Before clicking apply, I'm just going to display the full roster, and we can look and I identify players that fall on those teams that we're looking to restrict trade with. And here we can see Aaron Judge is one of those players that's associated with the New York Yankees who we're going to deselect. And the optimization model will essentially rerun and it will exclude those players from being passed through. So essentially it's excluding those players prior to sending the data through to the optimization model. So I'm going to click apply. It's going to rerun the model. This takes roughly a minute and 40 seconds. After which it's going to rebalance the team, determine from a wins perspective how many wins this optimized team is now predicted to win, and we'll determine similar players through the player cluster analysis. It's as you can see, it's rebalancing some of the players as we speak. So I'll move this out of the way. It just went through the bullpen process. But we would expect players anywhere that you see a New York Yankees player, Boston Red Sox player, Houston Astros player, we would expect those players to be removed from the output of this model. So we'll give this just a few more seconds, after which we'll kind of explore the recommended output that is going to be made towards the general manager. And then lastly, we'll explore the player analysis tab, which is a tab that provides the GM with the ability to do a bit more from like a self-service analytics perspective and really explore some of the underlying data and components that we had pulled into our model, just to see if there's any insight that they can possibly extract. So the output from this optimization model, which excludes the Red Sox, Yankees, as well as Houston Astros, this would be the recommendation that we're putting forth towards for the GM from a player and roster perspective. This team would have the highest probability of winning games. In fact, we would see their predicted wins here. They would meet the payroll constraint, and they would meet the team constraint as well and position constraints. So the model will finish running. This is essentially the final output that we would make to a general manager from a player perspective that meets the business problem that was originally presented. We've also identified who the starters are. So by navigating back to starters, we can view those starters on the baseball diamond. So right now it's just going through the process of redetermining who those starters are. And then, of course, it has rebalanced the statistics at the bottom to take into account players that were excluded. So lastly, we'll take a look at the player analysis tab that we've also included. The player analysis tab is it's essentially a dashboard that gives the general manager the ability to explore the underlying data based on their own use case. So they can come in and search for a specific player, search for players based on a specific position that they may play, or look for players that are associated with specific teams or exclude specific teams. Once they generate a list, so this is a list of all active players, and they can scroll through this list. There are relevant statistics around those players, such as batting statistics as well as fielding statistics. And they can essentially click on a given player, which will send that information through to the StatsHead API located on the right-hand side. It will also pass through that information directly to the player distribution chart beneath. And the player distribution chart is it's a good way of really understanding where this player fits relative to other players in that position. So right now we have Ozzy selected, who's a second baseman. And if we look at the batting average, on base percentage, slugging percentage, we can see where that player that we hover over, where they fit relative to other players in their position. So it's really helpful to understand from a distribution perspective where that player falls. And clicking on their name will send that request to StatsHead's API to pull back relevant information and filter based on their page there, which is helpful. It prevents the team from having to maintain this data. There's also a lot of relevant information on StatsHeads that a GM may be interested in possibly taking into account when making a decision to bring a player onto their roster. So again, we tried to make this dashboard as flexible as possible to answer as many questions as possible that a GM could have or face throughout the course of a season. And we believe closely working with GMs that we were able to not only satisfy the business problem at hand, but also create a dashboard that can answer questions going into the future. So as part of this project, we are working closely with Tableau to publish this dashboard to the Tableau server and make it readily available to others to access, whether that's via their desktop browser or whether it's via the Tableau app on their mobile device. So it should be available via the Google Play Store as well as the Apple App Store. The intent was to make a dashboard that was very dynamic and flexible for GMs to answer a number of different questions and solve a number of different problems that they may experience throughout the course of a season. But it was also to make this dashboard as convenient to access as possible. And we do believe that by accessing this dashboard via the mobile app, that GMs will have a unique experience that they can take out with them to the ballpark. On behalf of Team 62 Analytics, it's been a pleasure demoing the dashboard, and we look forward to showing some new features in the future as well. Thank you.